In this lab, we're going to cover functions, and I am essentially just going to build on the variables lesson that we did earlier. So I still have my variables file open, and we're just going to create a new script in here. But before I do that, I want to point out that having switched back over to Unity, I've got all of these messages here on my console. And if you're not seeing your console, you can get your console with Window and then just find console down at the bottom, and it'll bring it up. So this is where you see error messages and things like that. So this is a useful thing to have available. Sometimes I even like to get a second monitor or a third monitor or a fourth monitor if I'm feeling indulgent, and put the console up over there by itself so that I can see what's going on with respect to my output messages. But we're not going to do anything that fancy here. That would be a pain when it comes to screen capture. So we'll just leave it down here for now. And I have all these warnings here. You can actually ignore these in this case, because what it's telling me is that I created all these variables in my script and then I never used them. Now in production, that would be a no-no, because if you create a variable, that means you've allocated space and memory for it and then you never used it. So you should get rid of your empty declarations that you're not using. But I just wanted to point out that you're going to see these in the window and not to worry about them at this stage. All right, so we have our variable script that we created in the last video on, or the last lab rather, on variables. Let's go ahead and make one for functions. So this is going to be a bit dicey because C# is an object-oriented programming language, not a procedural programming language. And so you don't write scripts outside the context of a function. Really, you don't. So really what we're going to be writing is methods, but we're going to get just sort of the basic high-level overview of what we covered in our lecture. So let's go ahead and open that up. And as before, I'm just going to put things right here in this file. In fact, I'm going to get rid of some of the things that are here. Do I really want to do that? Okay. Tell you what, we'll just start that. We'll just do that part over again. So inside of mono behavior, inside of mono develop, it's going to give me my code. And since again we're working inside of an object, you can tell because it says public class. You can also tell sort of implicitly because you can't do anything outside of an object or a class code in C#. So you have to be writing object-oriented code. This makes this a little bit hokey because we're really dealing with methods, but I really just wanted to get these basics out of the way so that you could see them. So what I'm going to do is I'm just going to come down here below the update method, and I'm going to create my own function. So let's review the principal parts of a function. Functions are going to have a return type. They're going to have a name that, like variables, is unique to scope. It's going to have parenthesis. It's going to have arguments. It's going to be demarcated by curly braces, which gives it its own scope, and it's going to have a return statement if it returns something. So let's make something that actually returns something and make our first sort of method inside of an object. So the return type comes first. In this case, we'll make something that adds two numbers together. Fairly simple. So we'll do integer as our return type. We'll call our function add two numbers, and we'll have two arguments, which are first num, and we need a type for this, so it's going to be an integer, and then we need a second number, and we're just going to add first number and second number together. So I'll open my brace, I'll close it, and there are a lot of people that get actually upset as to where the braces are placed. Some people like them there, some people like them here. In C#, it doesn't matter. In fact, if you're using Visual Studio, it forces you pretty much into using this idiom. The only language where this is a problem is JavaScript, and I don't mean Unity script, Unity JavaScript, I mean real JavaScript. There's actually a problem if you do it this way. So if you're not working in JavaScript, it doesn't really matter. So I'm just going to leave that there rather than try to get it back up where it was. All right, I'm going to do this kind of the long way because, again, we're doing sort of these introductory labs. And you can do this in one line, but I really want you to practice this. So let's create a variable of type integer called result. And I'm going to set that equal to first number plus second number. And now let's use our return statement to return the result. So this is the anatomy of a very simple function. Again, return type, name of the function, parenthesis. There always have to be parentheses even if you don't have any arguments. Great example of that is right here. There are no arguments for the update method, which you got automatically when you created this script. And so it's just empty parentheses sitting up there all by themselves. After that, you have your arguments. If you have more than one argument, you separate them with commas. And then you have your curly braces that indicate your statement block, the code that makes up your method or your function. And then the stuff that happens inside of here, there's only one stuff that happens in here line in this case, and that's line 18 that's actually doing some work on the data that we send it. So one of the things that I think that a lot of people have questions about the first time they see this is, where does that come from? How is that a variable that we can use inside the function? And the answer is it's declared right here in what we call the method signature. The method signature is the combination of the return type, the name, and the type and number of arguments that it takes. So in this case, the method signature consists of an integer return type, a name, which is add two numbers, and two integer-based arguments. It doesn't matter necessarily what the name is. That doesn't affect the method signature. But in this case, the method signature does define two variables called first number and second number, and those can be used inside your function as though you had created them inside the function code itself. So that's a nice little shortcut. I didn't have to make two variables, first number and second number. I created them up here. All right, so those are passed in, and I can use those within this context, and that allows me to do this work on our data. We've added them together. We've placed the product of the addition into this variable called result, and now we're sending result back out of the function. So to use this, what we could do is we could say int simple math example equals add two numbers 5 and 3. And that's how we call it. So your function isn't going to do anything by itself. You have to actually call it to get it to do anything. So in this case, we've got this integer called simple math example, and it's going to contain 8. Now, how do I see that? There isn't anything that's going to automatically print that to a screen or do anything with it. We just have this number sitting there in memory. If I want to see that, I'll show you a handy little trick. This only works in Unity. You can say debug.log, and we can say the result of our simple math is, and now we can say simple math here. What I'm doing, this is actually, there's a fancy word for this, it's called concatenation. And what that is doing is it's taking the string, a hard string like the result of our simple math is, and then it's adding some dynamic variable value to it. And this is actually going to cast automatically for me, but if I really wanted to be explicit, I could say toString here. And now everything is the same type. But actually, if I'd left that off, it would have been fine. C# would have automatically cast that to a string for me. It knows that because I started off with a string, and it stands to reason that whatever I add to it needs to also be a string, and so it would do that for me. But here I've said toString and explicitly, and that's fine too. So what will happen is this will be printed to our console log when we run our game. So let's try that out. We'll switch back over to Unity, and the first thing you're going to want to do when you switch back over to Unity is make sure that you don't have any warnings over. Well, warnings are fine. You don't have any errors. And the errors are going to be red, a little stop sign here. This one looks gray because there aren't any. But it looks like a stop sign with an exclamation point in it. If you see anything red over here, you'll also see it down here. That's a bad sign. That means you've made a mistake and you need to go make a change. But here, it's fine. And so we can run this, and it's not actually going to do anything. So let's just run it so I can show you that it's not going to do anything. And then let's find out why. So scripts in Unity are just sort of objects hanging out there in space, and they're not doing anything unless they're actually active in the hierarchy somehow. So what I can do is I can add something to the hierarchy. It doesn't really matter what. I can add something simple like a cube and put that in the middle of the screen. And now that I have something on my hierarchy, then I can actually put a script on it. So I'm going to do that. I'm going to click Add Component, and I'm going to find Scripts, and I'm going to put my function script on here. And now I can see that my function script is here, and it's attached to this cube. And since my cube is in the hierarchy, everything that's in the hierarchy, Unity will actually do something with it. So when I run this, now I should see my message appearing in my console. And I don't. And now I can see when I click Run that I'm actually going to get a message down here that says the result of our simple math is 8. That's exactly what we put here. The result of our simple math is, and it's added our numbers together and given us the result. If you, for some reason, didn't see the message over here, if you didn't get it, then most likely what you have done is you have forgotten to save your functionscript.cs file. If you make changes to this, switch back over to Unity without hitting save, common mistake, you're not going to see the results of your changes. So if you made a big change, switch back over to Unity, it looks exactly as it did a few seconds ago. Probably you just need to switch back over and save your file and then switch back over and run it again. All right, so that is functions in a nutshell. You can make your own functions, or you can use some of the functions that Unity gives you built in. Now, these are special kinds of functions, and we're going to talk about these when we talk about object-oriented programming. So we'll hold off before actually talking about these. These are called event handlers, and we'll get into those later. So when you're talking about functions, you're really talking about methods because it's object-oriented, and you're making your own in here in Unity. And I guess the only other thing I'll point out is we talked about we talked about implicit typing in the variables lecture. I could have changed this to var, and since it knows that first and second number are both integers, this would actually work. There is no corollary when it comes to making the return types on your methods. It's not going to do implicit return types, nor is it going to do implicit variables in your arguments. That's not cool. I will show you. No, that's it. That's all we're going to do in this one. I'm tempted to go ahead and show you overloading, but again, that's object-oriented programming. All right, so those are the functions. And one more time, I really want you guys to get this. This is important. Method signature consists of return type, name, parenthesis, type, and number of arguments. And that's called the that's called the method signature. And then your code block and return if you need it. If we didn't need that, we wouldn't have to put that in there. So let's write one real quickly just so that we can see what it looks like. We can say void do something not very interesting. And this time we won't take any arguments, but we'll spit something out. We'll say debug.log. This isn't very interesting. And now we've got a function that doesn't take any arguments and doesn't have a return type. If it doesn't have a return type, then it's called void. There's another word that means kind of the same thing, and that's null. That works with variables. So if I do, say, string foo, if I can find the O key, there it is. Oh, goodness. Sometimes syntax completion is not your friend. Okay, so I'm going to say foo equals null. Okay, so null and void are pretty much the same thing. They mean nothing. They're literally, whenever you see those words, you should think of the word nothing. This is not the same thing as 0, because 0 is something that you can add to another number and get a result. Null is literally emptiness, void, nothing. Nothing is there. So those are the two words that kind of mean there's nothing there. You have to be careful with these. They can sometimes cause you problems, especially null. Void is not going to give you any trouble, but null will. So if there's nothing to return, then you can just use void as your return type. And you note that there is no return statement in this second function. It just doesn't do anything. Let me say that again, because that's not quite true. You'll note that in the second one, there isn't a return statement, and that's because the function actually does something. It spits out a log message, and that's it. It doesn't require anything being sent back to the calling, the caller. So let's put a caller in here so that we can actually see it work. Remember, your functions don't do anything by themselves. You have to call them. And so somewhere along the line, we have a caller. Caller is in C-A-L-L-E-R, not the top of your shirt, like that. And so we'll call do something not very interesting. Parenthesis, don't forget those. Even if you're not using it, if there's no arguments in there, you still have to put that in there. Let's switch back over to Unity. Be sure you save it. Switch back over to Unity. And it's running. We need to stop it and run it again. And then we should see the result of our simple math is 8. And then we should see this isn't very interesting because that's what our function did. All right, that's the functions lab. There will be a functions quiz in your section titled Things You Must Do on Time as part of your grade, or whatever it says, something along those lines. So go find the functions quiz, take the functions quiz, and now having completed variables and functions, you're ready to tackle object-oriented programming. A very important and somewhat large topic. The test for that one is going to be considerably longer than the variables and the functions test is. I think that's the longest exam that we have. So take lots of good notes, and I will see you in object-oriented programming.